activated, so your bar should disappear.
Okay, yeah.
Okay, I think that should be good to go now.
Pretty much.
So,
Almost everything else is in there.
HW3
It'll say, it'll say there's placeholders for all, so you have to do that, all placeholders for all.
Maybe, I don't know, I don't plug it into random projectors often.
I guess we need to determine which one.
It tells you that too. That's all stuff.
Alright,
Oh, where's that?
It's down in the.
6:04.
Change that. See, that
We'll
goes
give
to
people one more minute.
what thing is selected. Passes the data. Passes that to the update. So what? The update, you already get it.
Oh, good.
Oh, this is the data.
So
Not
that
coming
is
to
a-
Just on the speed. It was what was for free to rich.
This says, could not load the, why does it do this?
Yeah.
Could not load the.
They don't.
You guys haven't said that. I live in a dozen like
Where's it getting the fail from? It's getting the fail from the
most people's are. It's really.
I mean, is
all
it
down
getting
to
it from the update?
Basically,
Actually
Chris
calling
Johnson
update?
does a lot of stuff out
And then
of
that's
pocket
why it's
for
catching the error?
the institute.
Yeah, it's an update. Something's happening on the website, it's not.
He was the director of the CD Institute and is a
But
professor
the
at
update is being called.
computer science upper level. Big name in the visualization industry. I don't know if he does it with a one-time support or whatever, but Steam has its own funding sources that it can say that.
Yeah, there's not a lot of space.
Alright, well,
They have the camera.
6:05, we're gonna get started. Hold on, let me send you the slide link, because you probably want that. Let's close that to Slack. Okay. We said there would be homework
To
labs
finish this.
like, okay.
This is also a lab for
I mean, kind of old. When and where is the lab response? No, 110.
That's what comes with
Slides.
Let's make sure that's
So-
the proper link.
So A is the cell. So like A is the first column, this is the second column.
Oh, from
Yeah, so
homework.
like. You just use more data for your grade, that's all you need. It's kind of
Yes. What do you use?
Where are they adding up all? Where are they adding?
Okay.
Oh, they're converting it.
Smaller.
They're converting them for, okay. Converting them to this number.
That.
So they're just converting them from.
I think we're good to
string
go now.
number,
So,
all the old values.
we are going to start this lab by going over the solution to homework 2, so that you guys have a sense of kind of the things that, for the most part, we're expecting you now have a handle on going into this homework. Because if you don't, then you probably need to make sure you're up to speed on this. So, the homework 2 solution, everything is in tree.js. We've got our constructor here to start. and the constructor, as per the directions, creates an array of node objects. Our reference solution does this using the JavaScript array map command. If you remember from the lecture, the difference between a for each and a map command for JavaScript arrays is for each simply executes the function for every element. Map executes the function and returns the value for every element. So what we've got here is basically a for loop that's going through each element. For each element, it's creating a new node object with the name and parent attributes of the element from our JSON array, and it's returning that. So the end result of that is an array of node objects, and we're setting that this .nodes equal to that array so that the overall tree object that's being created has access to this node list. Does that make sense to everybody? Okay. So the other thing that we're doing in the constructor here is we are iterating through the array and populating the parent nodes. So this, we're going to use the for each loop instead of a map loop because we don't need the return value. And so it's this .nodes for each, a function that takes a node and goes through, and for each parent node, we're going to find. Find is another array command that goes through and returns all of the array elements for which the function of that array returns true. So if we do a find command with return n.name, n being our original, n being our inner loop and node being our outer loop here, we can go through and ensure that we pick kind of for every node, we're going to set the parent node by looking through that entire array again and looking for where the name matches the parent name of our original node and our outer loop. So there are two loops going on here. Yeah?
Are you going to post this online with null solution?
I need to double check with Alex whether or not we're posting the full solutions. They will definitely be available with all the TAs in office hours. But beyond that, I am not positive. This video is streaming though, so there's that.
You might as well skip the step and just post it online.
Yes, but I didn't get permission to do that specifically, so I am going to hedge my answer there until... Okay, so the second function here is our build tree function. The build tree function starts with populating the children. This is doing a for loop going through, and for each node, it's checking if the parent node exists, and then if it exists, we're adding our specific node as a child to that parent node, right? So this is actually a single loop that populates all of your children because you know that every single child has a parent, and that node exists in this .nodes, except for our root node, right? There's one parent name that's root for which we don't actually have a node in this .nodes. So if you go through and you check whether or not kind of the parent node is undefined based on what we set, i.e. the parent name wouldn't have found anything in the find command earlier, then we can simply append the child to that existing parent in one go without any additional looping. We are going to grab the root, which is the result of a find command, like we already talked about. This is just checking whether or not our parent node is defined here. So that's just a shorter way of saying this is going to return basically whether or not it'll only return true if parent node is not defined. And then assigning levels and positions, we're calling our next two functions. Scroll on to assign level. Assign level is the simple one here. And basically, this is a recursive function that calls itself. So basically, you go through, you have a given node and a given level starting at root and 0, and you set the node's level to the level passed in, and then for each child, you run assign level on that child and level +1, right? And this is going to go through your entire tree and make sure that every parent-child relationship is kind of, children are always one level below parents, which is exactly what we want. Assign position is the one that is slightly more complicated. Because in assigned position, we are actually going through and ensuring that our node position is the minima of all of our children positions, which means that we at least the way we implemented it here, there are other ways to implement this, but the way we implemented it here, you're going to recursively assign all of the positions to the children, and then after that, assign the position to the parent. There's an outer for if loop here, and that's because you have to handle the case of dealing with leaf nodes, i.e. nodes that don't have any children in your tree, the very bottom of the tree, right? And in that case, then you should just be assigning kind of the position passed in. So in any case that's not a leaf node, we're going to handle all of our complex logic here for doing this. So we're going to have this outer basically for loop that goes over all of the children in our given node. We're going to create and track kind of the position that's been specified to be passed in. And we're also going to look at what the next available position is, right? And this is because the specified position for kind of the first child of a given object is, say, 0. That was what was passed in for all of the different children, or 1 for all of the different children. Assume we're doing root node, right? Root node is 0. All of the children of root node are going to get passed in 1, or maybe 1, 2, 3, 4, right? Depending on how you actually specified your recursive function. But to ensure that we don't have any overlaps, we need to make sure that nobody else has assigned that position yet. So basically, what this available position function here does is this is going through and checking what is the maximum position that has been assigned so far at a given level, right? So this is going to go through, and there's a max command here that is looking at the result of a filter command that returns all of the nodes at a given level. So it basically goes through all of the nodes at level 1. All of those nodes are initially assigned a position of -1, and we know this from the nodes.js file. That's how they're initialized. So anything we've assigned, right, as long as we keep track of what we've assigned so far, we can always assume that the maximum thing we've assigned +1 is the next available position. And so that is exactly what this is calculating. And so then you're just going to do a check whether the passed in position that's been specified is greater than the available position. If it is greater than the available position, then we're going to assign the position of the children to the specified position. If it's not, i.e. if the available position is greater than what's specified, then we're going to assign the position using the next available position. Does that make sense? Okay, and so you do that for each children, and then you go through and you look at, this is just another function that takes all of the positions of the children, right? This map command returns an array, and we're doing math min over that array to return the minimum position of all of your children. And that's what we're setting our node position to. And that's how we set all of our node positions in our tree. Finally, we have our render tree function. For our purposes, I created a custom convenience variables here to pass in, just so I could modify and change things quickly. You could have these hard-coded and it wouldn't really matter. What's important here is that you need to initialize the SVG if it doesn't already exist. So the way we opted to do this here is we look for a specific ID that's set,
if the selection containing that ID is empty, you could actually replace this with svg.empty. There's a actual D3 selector command in v4 or v5 that I wasn't aware of that makes that much clearer. But basically you're checking whether the selection is empty, and if the selection is empty, then you're selecting the body of your HTML document, appending the SVG, and making sure it has that ID. And if the SVG is already created, well, it's going to be picked up here and you're not going to execute that. So once you have your SVG selected, you can style it, add kind of the 1200 by 1200 that we told you to specify, and then scroll, render edges here. So that's the next thing that's going to happen here. So, and the reason that's the next thing that's going to happen is because the SVG render order matters. When actually doing this, the most natural thing for you guys to do is probably to get the circles of the nodes first and make sure that those were in the right position. But for the purposes of the actual SVG creation for the final document, the edges need to be rendered first. So what this function does is it goes through and we've got a update, enter, exit, merge loop like we talked about in the last lab. This goes through, it selects all the lines in our SVG, and it's doing a data bind to all of the nodes that have a parent node, right? Because if you think about a tree, every single node, every single child node has one edge from that child to its parent, except for our animal node at the root, which doesn't have a line to anything. So basically, what we've done is we've gone through and selected why is there a box there? Oh, okay. Never mind. We've gone through and selected lines and done data binds to every child except for our root, every node except for our root node is what's happening right there. We do an enter selection on those and append lines to that. We have no exit loop because this is not going to be run, but you could uncomment this and it would be the exact same. You merge the existing and new selections to create a set of all the edges you need, and kind of you then update the properties according to the data. You could, and we would accept in the case here, chaining these together and doing something like all edges equals our enter selection of the new edges plus append line to that and merge that with all edges. And the reason this works right here is because we know this function is only going to be run once. But if this function were ever to be run multiple times, then the ability to break out your exit loop becomes super important here. So in general, we do not encourage you to write your code like this. Always kind of write it out with all four things, just so that you've got a consistent framework to work with. So in updating our edge attributes, we're going through and we're setting the x1, x2, y1, y2 as kind of, this is level and parent node level of a given node, and we're multiplying it by some scale factor and adding some offset value. And that scale factor and offset value are going to be the same scale factor and offset value we'll use for our circle nodes. And so you do that for both your x positions and your y positions. And then the next thing we do is, render the nodes. So there are two versions of this. So full credit is we wanted you to create groups and transform those groups. This is how we're going to go through it. If you were just going to, if you didn't worry about the groups, I think it's like 1 point off, that like if everything else looks correct and you've just got 14 circles, 13 lines, 14 text elements all together in your SVG. If you were doing that, it's going to look very similar to the generation of lines, and you're just going to be changing attributes for the circle command and for the text command according to each node data set. The slightly different thing is if we are using groups, you're doing some sort of selection. Here we created a custom class called node group. You could have done a select all on the group elements as well. You do the selection on that, you bind the data, you kind of do your enter, exit, merge in the exact same format that we did before, and then we update the properties. And in this case, because we have group elements, what we're doing is we're adding a class node group to those created group elements and the ones that potentially already exist, though none do in this case. We're adding a transform attribute that maps a given node to translate by our complex scale factor of level and our complex scale factor of position. And so that's going to just handle the group translation overall. And then, because you already have each group, you can simply append a circle to that group and leave the x position and y position at their default values of 0. So the only thing you have to set at that point is the radius. And similarly, you can then just append a text element that is also centered at 0, 0. We gave it a class so it renders in a specific way. And we set the text value for that text element to the name, uppercase in our case, of the name attribute of our given node. So if you were to scroll down a little bit further, the partial credit version of this commented out here is basically, this is just, we're doing the same enter update with circles, and then our attributes for circles are now CX, CY, and radius, because we don't have that translation. And similarly, if you were to look at rendered labels, then it is the X, Y, and text value that need to be set, right? This all makes sense? That is all of the code for homework 2. And this took us a little bit longer than expected. All right, cool. So, any major questions on homework 2?
I think it was just the assignment position was really.
That was probably the hardest part of the homework.
Really tough.
And if you screwed up the assigned position, we are not going to cascade those points into the grading. So, cool. Let's then talk about homework 3. So, for homework 3, we're going to start by actually looking at the markdown document that you have been provided as part of your homework assignment. We are going to move over, and here it is right here, and we are going to walk through the basics of what needs to be able to, what you need to know for this homework assignment. So, HTML. So, let's talk about the DOM API. We talked about this briefly in class. This is different from D3, but has much of the same functionality as D3. Is this one mine? Yeah, right. Okay. So let's come over here. So, for a lot of detail, you've got what was covered in lecture. Yes?
So I had a question a bit before this.
Yeah.
So the staircase function, so can you just show it over the dataset 4? Like,
Yes. So, I think I know what your question is. I'm sorry. Here. Dataset 4. We are not just ordering the elements, right? What's important is that, well, let's put it this way. If you did order the elements, we're probably still going. The purpose of this particular function in this part of the assignment is to make sure you know how to select objects and update attributes accordingly with data using just JavaScript and DOM accessors, right? So if you're going to run sorting and update the positions of the sort, that's showing us that you can do that. If you're going through and simply updating the length of every single bar to be sum 1 through 10 like we did here, that's showing us that you did that. So in either case, you are almost certainly going to get full credit. But what our reference solution is doing is going through, and I think there's just like a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we're doing some sort of underlying scale factor for that that's being assigned to each element as a length command. What's important for being able to do that is knowing the difference between kind of your D3 selectors that you used last time and the DOM API. The DOM API was covered in class like 2 weeks ago, and there's specifically a kind of lecture tutorial that'll go through it in lots of detail. But for your purposes, the core functions you are going to need are mostly covered here, and this is your quick translation. So if you wanted to select a given element by a single ID, there's an equivalent document get element by ID. In the same way that D3, you use D3 select to select objects, for the DOM API, you use document as your base and then call functions on that object. D3 select returns a selection. All DOM API calls, for the most part, return an object, right? But then beyond that, there are often kind of core functionalities that are the same. So for a selection, if you wanted to select all potential children nodes of any class, you can use the CSS star selector. If you want to select all children of a given element for a given object, you use object.children in the DOM API. If you want to do append object in D3, as we did in the last assignment, you take your selection and you append a string that contains the object type, whether it be rect or circle or G. If you want to append that object over here, you literally do append child with the object itself. You can get the attribute of an object using getAttribute, or in the case of D3, selection.attribute, and you can set the attribute using setAttribute, attribute value, and similarly in D3 selection, you just use the same attribute command and provide both the attribute and a value and it'll set, right? And so the core things you need to be able to do for that creating kind of a staircase function in JavaScript, aside from using arrays, you should be able to do pretty much all of that using this set of functions or a subset of these. Okay, we are going to go on to the anatomy of a D3 scale, but we'll do this in context. This is coming to part 3 of our homework assignment, where we're using data to reshape things. The bulk of the assignment is adjusting SVG elements based on the data, and we use scale functions to do so. So rather than having the complex times some variable plus some variable thing that I had in the homework 2 solution, what you can do is you can use D3 scale objects. So a D3 scale is a function that takes inputs within a specified domain and produces outputs in a specified range. And so in code, that looks something like this. For a linear scale that simply kind of translates in a complete straight line from one domain to the other, you've got my scale is equal to D3 scale linear with a domain going from 0 to 10 and an output range going from 0 to 600. So in this case, we've got a continuous variable mapping to continuous variable by some linear function. D3 algorithms, if you want, you can click on the link and go through and read all of the documentation on scales. For the purposes of this assignment, we're providing you with linear scales already. You shouldn't need anything else. But knowing that scales get more complicated is probably going to be important for some of your later homework assignments. And especially in some of the later homework assignments, you'll recognize that there are scales, whatever our selection is, update our given attribute as a function of that scale. So that's how you're using the scale, is simply as a way of transforming the data values, and it's basically a wrapper function for some of the sorts of calls we were already doing in homework 2. Is that clear to everybody? Cool. So then the next part of the homework assignment, D3 generators, get to the fact that as part of this, in part 3, it talks about D3's line and area generator functions for JavaScript objects. And if you look at the code we provide you in script.js, here are kind of the scales we provide you. And in here we've also got some line generators and area generators. So the question is, what the heck are D3 generator objects? We haven't talked about those in class at all. So generators are also functions, and these ones transform data into relevant SVG shape attributes. So in the case of our line generator function, assuming we have some scale that we want based on our index and some scale based on some attribute value here, like we have in what you've been provided, that's going to generate this exact same string here for a path element. So D3 line generates SVG kind of content, the content for either a path or a polyline or things that have this same kind of string format that you manually coded in assignment 1. So rather than sitting there and manually going through and encoding that for each data value, that's going to do it automatically for you. And then you're going to set the result of that, having passed the data in, to the D value of your path element, right? And so this kind of updates scheme is how you kind of take a create a generator, and bind the result of that generator to a given object selection. Does that make sense to everybody? Yep.
So we already have that path on the SVG. Is that what you're saying? Or it is creating that SVG?
So in this case, assume that our selection is this path, and we are replacing it with a different path, is the easiest way. So our data set may not generate this exact same path, but what this is going to do is it's going to update that value, and that path is now going to render as something else. Now, if we had a blank SVG and no path there, then this selection would need to append a path first and then set the attribute of it, right? So in either case, it really doesn't matter for the core part that we wanted to get at here, which is how you're setting a given attribute for a specific type of SVG object. So here we've provided exactly what that looks like for a line generator. For the area generators, you can see the exact way that that works using the example code in the D3 API, right? So given that we only, there are also lots of other types of generators. There are histogram generators and all sorts of complex things. Unfortunately, there is not a, because Jen just clicked on it, there is not a quick kind of quick selection to all of them. It's not there, Jen. I've already checked. So you're actually going to have to do a search command on this, like Apple F, find, and if you do generator, that's a Google search down here. Here we go. You are not a Mac user. Right, so this is our histogram generator right there. That's access generators. This is a ribbon generator, a nest generator, a contour generator, geopath, geocircle, arcs, pies, lines, areas. And if we want to look at area, we click on area and we go here. And it'll give us nice examples of exactly what that data bind looked like and how we use it and all sorts of more complex things you can do that you won't need to do for this. But like all of the information and detail is there if you want it and you need it. All right? But the basic principles of generators and what that's going to look like, we've kind of covered. Then parts 4 and 5 of homework 3 assignment is basically dealing with more events, specifically interaction events, listening for clicks on a scatter plot point, logging X and Y coordinates, having mouse hovers trigger things using JavaScript, and then updating your data consistently as our data sets change, right? And so both of these things, in terms of our final homework solution, look something like, okay, we can mouse over these guys, and we've got interactivity here. We've also got the fact that we can take a random subset, and it'll re-render things automatically for us, right? Both of these things we are now going to discuss and go in depth a little bit more using an observable that was created, and here is a link. Pull out your laptop, and we are now going to walk through this, and the easiest way for me to do this is actually going to be to stand over here. So the big part of part 5, which is updating data, is making sure that you have this update, enter, exit, merge loop down pat. If you don't have that, your data is going to get all screwed up as you try to switch data sets. So what exactly is going on here? We spent a lot of time drilling into this a little bit last lab. At the same time, I probably started a little bit lower level than most people were ready for, and I recognize that, so we're stepping this back a little bit and reviewing this a little bit higher level, but also looking at kind of a little bit more detailed version of what's happening under the hood in the process. So, below, we've got an SVG containing 3 small rectangles, my SVG. Here it is right down here, right? And if we expand this, we can see it's simply an SVG that has kind of 3 rectangles in it. That's it. So, if we do a D3 selection of my SVG and select those rectangles, what does that result look like? We get the D3 selection has groups. It's got a parent, which is the actual SVG element, and this groups contains a list, an array, a node list of those 3 rect elements. Right? This is kind of what we expect. Now, what happens if we do the exact same thing and do a data bind? Well, all of a sudden we can immediately see that now we've got enter and exit array elements, exit elements that we didn't have before. And we can also see that, so this was our data set here that had 5 things. Our original groups, which had kind of the 3 rect elements before, still has the 3 rect elements, but its array length is 5. So there's spots for every single data item. If we compare this to our enter, it has 3 empty spots at the beginning, because we already have those elements here, and placeholder elements in the last 2 spots. Our exit command is an array of the same length as our original input, 3 elements, with empty things in each of those slots, because we don't actually want to remove any of the elements in this case. We're going to reuse the 3 that are there, and we're going to add 2 more, right? So if we look at the .enter selection that we're using, what that's doing is that's literally returning as groups the exact same enter array we saw up here. And if you were to do that with exit, you would see the exact same thing. I think we do it right down here. That's the exact same. Now your groups of the selection is the same as that exit array that we saw right here. And in order to convert these placeholders to actual elements, we do append rect. And if we do that, what we get is the array with 2 rect elements, right? And so what our merge command does is our merge command goes through and it literally takes the union of our original selection array and our enter array. And it's basically where there are blank spots in one, it's pulling the element from the other, and where there are blank spots in the other, it's pulling the element, right? And so it's just going through, and from the first array, it's taking the first 3, and then it'll take the last 2 from the entering array. It does not matter what order you do this enter merge update with. So if we did updating and entering here, it'll be the exact same thing. Doesn't matter, because all it's doing is a union call. Yeah? It is in the end of the slides that are posted to general. So you should be able to click through the slides, and You can copy it right there if you want real quick, or you can go through the Slack channel to the slides, click to the last slide, and you should be good to go. Okay. So that's exactly what's happening with kind of the enter, exit, merge under the hood. And now we can go through and kind of update each set of objects as you go, kind of each subset of those objects. So what I've done is I've created an animation here that's going to go through, and it's going to go through and do this update. So here's our data that we're binding. We click update. It's going to grab the first 3 elements. Those are our update ones, and we transform them. We take our enter elements. We're running some sort of transform on those. We do a merge step, an exit step, of which has no effect right now. And we do merge and transform them so that those data values get mapped. So now if we go through and we remove 2 of these, back down to like 3, and we do update, our update selection is going to contain those 3. Our enter selection has nothing because we don't need any additional things in there. We have to remove some. Our exit is going to select those 2 and remove them. And then our merge command is going to take kind of our empty entering and our existing and kind of do transformations back. And so this kind of scheme will allow you to do all sorts of updates as you want to and go through, and this is your data update scheme in a nutshell. And hopefully at this point we've kind of showed you exactly what's going on under the hood to help you understand exactly what you can do there. And then if you're interested and you want to dig in, all of kind of those fancy transformations that we did, right? Up here we broke out kind of the updating subset, the entering subset, the exiting subset. There's a run state here that you can click on this thing and expand and look at exactly what we're doing to each of those subsets as those transitions. And so you can do independent things to each of those different things and you get far more control. And so here's an example of, we did it for illustrative purposes. You may want to or need to separate your enter and updating commands for non-illustrative purposes when you're doing your various assignments. But this is the power and the importance of that enter, exit, update loop. All right? Any questions on that?
The update, is that an actual, is there a call, update call?
So the
Like the enter and the exit?
what happens is the data bind call
That's the update.
automatically converts it to an update selection. So, and we can actually show this. So let's do our update selection. We have 4 elements right now. We're going to shift this down to 3. This array is linked to the one we've created down there. So we can look at our original selection there, which here we're going to have to run that one more time. And those will be the 4 elements that are currently right down in there. And by doing the exact same thing with the data bind here, our groups only contains 3 elements. So our updating set, this is running the exact same code as this. And here, groups has 4 elements. Once we've done the data bind, our groups only contains 3 elements. So that update call is implicitly happening with the data bind. Cool.
So why were there 4?
Why were there 4? Because right now in the SVG there are 4. Right? So this call right here, select the SVG and select all the rectangles, is doing exactly that. And there are 4 rectangles that are being selected. Once you've bound the data, it's creating update, enter, and exit selection, subset selections, right? And so that is this call right here. We bound the data. And so of those 4, we only have 3 data elements. How many of them need to update? Precisely 3. How many of them are entering? None. And how many of them are exiting? Precisely 1. Right? So the data bind has implicitly created each of those different subsets. You simply use the original selection to access updating, which is why we set updating equal to this here for illustrative purposes. And if you want to access the entering, you use the .enter, and if you want to access the exiting, you use the .exit. But the data bind call creates all of those in one go, and then you just are accessing the subsets of them. Does that make sense? Because this is like the critical important stuff. Like, if you're confused about this, we want to make sure we get it ironed out. Yes?
So I'm not clear about how the attributes remain. Like suppose we have like circles and then we do a merge. Suppose there were like 10 circles in the beginning.
Mm-hmm.
Then we have a new data that has like only has like 3 or 4 of them. And we put that, how do the attributes say? Does the circle, those 4 circles still carry the same radius and like the center and all those values?
So let's do it. 120, 345, 100, 40. So we're going to run through and we're going to create like, what? 1, 2, 3, 4, 5, 6, 7 objects that have data values to them right now, right? And okay, now we only want 3 of them. So let's take like the last 3, because we've already been including the first ones up there earlier. So we only want 3 of these. We've changed our data. If we select all the rectangles, we should see 7 rect elements. And each of those rect elements have the data that we saw right here, right? If we do the data bind step for our new data, now we have exactly 3 rect elements with only the 3 data elements we have here. And if we'd updated these to be something else that weren't a subset of our things before, then this updating is going to have those values instead. So what that data bind did is that data bind, and look, if we look back at our original selection, all of those original values that we had in there are currently there in the SVG because we haven't changed anything in the SVG yet, right? But what we have done is changed the values in kind of our selection. And so our underlying selection is going to be able to access the exact same underlying element and do updated calls to it. So what's going to happen is when we do our merge step, and the easiest way is to kind of break this out into, we take all of our merged things and we are going to update the Y position based on the index, and we're making the width equal to the data value that's passed in. At that point, only once we've made these attribute updates does the actual SVG change, right? So the SVG doesn't actually change, the selections change, the selection is carrying a different data value, but the actual SVG doesn't actually change until we've called kind of for a change on those particular elements through kind of using the merge kind of subset and actually doing attribute calls to update the underlying SVG.
So my question was like, at the very bottom when you assign the Y position,
Yep.
so suppose you remove that, and I mean you don't reassign the Y position. What
Yeah,
happens then?
so if there is a, so say for example, and we'll actually have some kind of use cases for this later, but say you set an X position and a Y position, or the easier way is, say you wanted a stroke kind of outline, and then you switched it to a fill for something else. Is that stroke still there? Absolutely. So how do you remove the stroke? You have to actually set the stroke attribute to null, at which point that will remove that attribute that set attribute. But if you don't overwrite an attribute, that same attribute will persist in the SVG. Does that make sense? Does that answer the question? Maybe. Let's revisit if you still have the question after we've gone through the interaction stuff, because I'm hoping that that will kind of answer that question. So, there is an exercise here that if we have time, we'll attempt to have you guys do, otherwise it's take home. There's a solution here that you can kind of expand to look at if you can't figure it out. But the other thing that's important to this homework assignment is the ability to enable interactivity, which looks something like that, right? We've got a mouse over event that is changing our color, updating our stroke width. You can even update size if you wanted to, right? But an ability for specific events like mouse over and mouse out to affect what you're looking at. So we've got a code block here that's doing it. We're going to break this down part by part. So part one, you should be familiar with. This is selecting the SVG, grabbing the first and only circle in our SVG if it exists. So we're attempting to select it. If that selection is empty, we're appending one. If it's not, we skip this and we're using the one that's already there. So like the very first time this got run, it's no change, but if we went through and changed our fill or our stroke width here to say 3 and ran this again, it's going to use the existing circle in our SVG in updating that stroke width. Okay? Part 2, there is a change. Some of you may or may not have noticed as I scrolled by very quickly. In much of homework 2 office hours and in a lot of the stuff that we've talked about so far, we've only talked about setting attributes like CX, CY, R, and we actually used to set kind of fill as an attribute and kind of stroke as an attribute. Here we're setting them using style. Why? Does anybody have a sense of what the distinction is? Yeah, the style is just the CSS version. So a lot of the CSS kind of attributes, SVG can actually kind of use as their own attributes. Setting the CSS creates a slightly more expanded thing, but for all of the basic things you're doing here, you could set these all as attributes rather than using kind of a single style. But here's what that looks like in the actual underlying DOM. So if we do this, we do attribute here, an attribute here, an attribute here. I'll change this back to 2 because it doesn't matter. Right? Well, now each of our circles have attributes that include CX, CY, R, fill, stroke width. Right? Each of those are independent things. If we change that back to style, last one, and rerun this. Well, now our circle attributes are CX, CY, and style. And style contains our fill, stroke, and stroke width.
So what's the best practice to use a given concept? Like I've used, for example, in the assignment I'm using attributes.
So, in the case of the assignment, I don't think it really matters much, at least because you're doing fairly simple interactions. The benefit of using style, though, is that this style kind of string here, we can pull out as its own consistent thing, which means that we could save this as a variable and hold on to it and then restore it later, or update something else with that exact same style without having to do a whole bunch of different attribute calls. And so what this means is that we're going to talk about event handling next, but you can use style as a way to go through and to handle the restoration of kind of having changed things and changing them back as part of your mouse over events. So we'll start with the basic version using attributes, and then we'll show you exactly what that looks like in terms of what I'm talking about. Yes?
So I remember in lecture yesterday, Dr. Alex, that's for him. He made a very specific point of doing your styling after the merge, right?
Yes.
Does this dot style assist in that? It would be in the
No,
same
this
position as an attribute.
Yes,
anyway,
so it
which
should.
all have to be after the merge, right?
Yes. That's the actual dot style doesn't assist in that, but you use it in the same way as you do an attribute update, which you want to do after the merge, usually.
And is that for when you're doing interactive stuff, or just all the time?
Easier to say all the time. Because
when do you run into bugs if you don't do your styling after the merge? I kind of didn't catch that.
so that bug would be the equivalent of, say, up here when we were doing kind of this, and I added a fourth element here, and basically you could imagine I go through, I use my enter, my updating, my enter, and if I don't merge these, and I take my selection and restore it back, then it would create the bar chart for just these three objects. And this one would be left sitting over here unchanged. Right? So that's what would happen if you kind of ran the attribute update without having done the merge step. Then you're only going to get the original updating ones and update the attributes of those. You won't get the other kind of entering ones. Does that make sense? Cool. No problem. So, interactivity. The last bit here are these on mouse over events. So basically, D3 has a way of setting up listeners on selections to watch for and handle events. And when we say events, you can open this in a tab and you can see the insane master list of kind of D3 event handling with bubbling and whether they're cancelable and details and stuff that you don't need to know for this assignment. Okay, but the reference is there if you want to go digging. The basic method for adding an event is the on function. So again, more detail in the API, but you're going to take a given selection and you're going to call on with a type name and a listener function. The type name is a string corresponding to a DOM event type. So in our case, these are, there's a long list of them here, but you've got drag over, drag start, drop, end events. We are using mouse over and mouse out. These two. Mouse enter and mouse leave are very similar, but have to do with whether or not the call bubbles and stuff that, again, you don't really want to or need to be worrying about at this point. So for the purposes of kind of this assignment and the next assignment, you're going to need mouse over and mouse out, and you're going to need click events. Those are the kind of three. So you'll have, in this case, we're setting mouse over and mouse out. And what is our listener function? The listener function is simply a function that, like with any other D3 object selection, is passed a data, a bound data value for kind of that given selection, the current index of that selection, and the overall group of nodes along with it. So when we were updating kind of a random attribute. You could go through and kind of use the data or the index. We never had any real use for groups, but if we went up here and looked at, let's see, where's the right place to look at this? DIG. I don't think there's a simple way. You can actually go through and console log this in, yeah, question.
So on the homework assignment, it says that for the mouse over effect, we're only supposed to use JavaScript. Like
This is all Javas.
D3 select is JavaScript still.
Yeah, I don't think on this part you can use D3. I think.
This part because it just says using JavaScript.
Just one of the parts you have to use JavaScript.
Right, because the first one it's like specifically don't use D3, right, on the
Yeah,
staircase.
I believe only part 2 is don't use D3. It's right here. Let's look. So part 2 is using only JavaScript in the DOM API. Part 3 is reshaping things with D3. So
So the second component it says you can use D3, but that makes me think the first component you cannot use D3.
This talks about changing colors in the bar chart using JavaScript. It doesn't say anything about you have to use JavaScript for the scatter plot.
So not for the scatter plot click. You do for the mouse hover. I'm pretty sure. Can you pull up the solution? Let's double check it. I pull it up, but they're staring at my screen.
The solution on your laptop?
The solution is on my laptop, but I'm having her pull that up.
Oh.
Mind if I just
Get all that.
It doesn't matter whether it's.
Yeah, and I put it to do it in JavaScript here. So, but I want to make sure I know what that update. No, we did it. And I pulled that, I'm pretty sure, from the previous version of the solution. I would say probably it needs to be in JavaScript. Do you, what is the relevant command? I don't know it. And you do. So, yes, good. We're going to go over this again real quickly. So
you can't use D3 on that.
for that particular part, no, according to the assignment, and we will do the grading of that equivalently. So I'm going to have to update our solution accordingly.
We were working on that, and
You can use D3 in everything that we're talking about here for the click. You can use D3 completely in the next homework assignment. But for that particular part of the question, or of the assignment for homework 3, you will need to use the JavaScript binding for event listening. And that looks like, I'm assuming that there's DOM events. It's probably, you know what, yeah, okay, so it is and I'm assuming there's an on mouse out event as well? Yeah, so what's going to happen there is, and we can actually just do this live to check. So right here, we're using the D3 selection with an on event. Okay, let's assume we want to update this to use pure JavaScript. We need to actually take the underlying elements from the selection. So that is the nodes list array, right? That is, you can grab that from the D3 selection using nodes. So what D3 nodes is now, if we were to console log it, is, and we can do it right here. We're going to add one, and we're going to do D3 select, circle nodes. So yeah, here, this is doing it for grabbing our style already. That is our circle element that's right there, right? So if we didn't have the nodes, what it's going to return is the D3 selection, which contains the node list of that. Nodes takes that array. So now we have an array of the SVG elements. Now for each element, right, you can now do a JavaScript for each and use the exact same kind of, let's say it's element. We are going to add a mouse over event of element dot on mouse over.
You have to add an in listener and then pass it.
Okay. So yeah, I will have to double check the actual JavaScript for this. But how you get the D3 selection to being kind of the actual SVG objects is this. And then you can go through and do for each and add the equivalent event listeners using the standard Java calls, and you're using straight up JavaScript for that. Does that make sense?
This is using D3.
So if we wanted to change this so we're not using D3 at all, we talked about the DOM API. What's the equivalent to D3 select of example02 ID? Document select item by ID. Right? Something like this, right? And
Element. Sure.
dot
Element by ID?
Yeah.
Also like element.
it's whatever is actually in the earlier things. The JavaScript stuff that I'm doing live here is me trying to remember stuff off the top of my head without Googling stuff all over the place. This is not how you do computer science. So this is pseudocode at this point, right? Query selector all. Right? And now we've got query selector all circles
Misspelled.
and
Select, misspelled selector.
right?
It's still.
I know, but I'm just going to actually, we're not going to run through and do the assigning for each right now, but we're just going to make sure that we're going to show that this is going to return, let's see, because document by ID doesn't use the hashtag, right? So the ID is actually just going to be example02.
So it will be get anything by
Select.
it's get
Oh, get element.
Get element by ID. See, this is why I have, and there you go. That is the exact same node list that we had before, right? So yes, you can go through and translate everything we're talking about to DOM API calls, and you will need to do that for that particular part of the assignment.
What Sandra was more elegant, but what you could do is you could even just go into the elements like Andrew and I did and assign the on mouse over the function that you want to use. Or, I guess,
You go back up off to that.
Yep.
Okay.
Cool.
Thanks.
So what's important is you're going to have some sort of listener and some sort of function for mouse over and mouse out events. And what we're doing in this particular case right here using D3 is we're setting the fill object to something else, setting the stroke width, and then we're resetting them to the values that they had before, right? And this results in kind of that exact same interaction. Now we talked about using the style attributes and what that allows us to do. So the alternative would be to grab the styles from the actual elements of our selection. So this is a map command that returns the style attributes of each element. So this is going to be an array, and that's the exact same array that we saw. Why is that? I'm just going to refresh this. I don't know what I screwed up there, but it'll work with here. So right here, this circles, nodes, map, the style, that is exactly this. This is your circle selection, nodes, map, the style. You're getting these style, this style array back for styles. On mouse over, you change it to whatever the heck you want. And on mouse out, you use the index that we've passed in with the style array created from the earlier set of objects, right? And we can go through and update this in that exact same observable and show that that push pop works exactly as expected. And actually, we only need to change the second one here. Oh, hold on. What did we do? Probably that. Nope. Let's see. Circles, nodes, map, attributes, style. I had this working before. Again, this is why you don't do live demos. Circles on mouse over, on mouse out. This should be the exact same style, which is exactly what we expected. Oh, well. I'm not sure exactly what I did wrong here, but styles. We should see exactly what we wanted up here. Stroke is 1. Other than stroke width is 2. Our D3 selection should go through, grab the equivalent object. Also use this to do the exact same thing. Why is it not getting my mouse out of this? Compare to oh, I had it working earlier and it is not working right now. Let's try that one more time with copy and paste, just in case I did something screwy. Nope, I have never worked. I did have it working before. You can use the MS listener. in that way to update the style. I'm not sure why it's not working in this particular example at the moment. In any case, the basic functionality in terms of you don't need to use the styles to do that. I was going overboard here. You may want to use it if you want to attempt this exercise, and this exercise is basically going to be adding the exact same sort of mouse over functionality to kind of these objects in this updating array up here. There's a solution that's included. Yeah, question?
Yeah, that function which is select query or something like that for what does it do?
So it's like an equivalent of DOM select all. So basically, with query selector all, it's not specific. You can pass in like classes. I mean, you would do an ID because you only do one an ID, but so you could do a class or you could do an element. So if you wanted to do like query selector all, with div, like select all the divs. But if you're like narrow down your selection, so you select the ID of that is it a div or a group, a div of the bars for the bar chart, then you can query selector all. The selector is rect, and so it just gives you an array of the rect nodes.
Oh, okay.
So,
Yeah, and I believe some of this is available in this tutorial that's on the website for DOM manipulation. The rest of it should be in this MDN reference document that is linked, and you should be able to find kind of the relevant sets of functions that you need to get those equivalent D3 subset selections. Cool. Any other core questions? Otherwise, I think that pretty much covers everything you need to be able to do for this assignment. And we'll have office hours tomorrow if you've got major questions. But, yeah. Yeah, we'll just pull it up right here. So we've got a staircase function, that's part 2. It's probably fine. As long as what needs to happen there is I need to see that you can get the subset of elements that can actually update an attribute. So yeah, you're getting it from the data and you're updating the position rather than changing the lengths of them. That's all it should be fine. So the other interactions that exist here are when the data set changes, every single plot should change, and all of that should happen
like you're not selecting this
update, right? This update function is what's going to be called in all of this. So data changes, it's calling update to the data. When you're clicking a random subset, right, it's a random subset that you're going to win. What that's doing is it's filtering the data based on a random subset, or you're calling change data, that internally. So you've got like one change data function that is being linked into all of your various. Yeah, so you're adding something there to make sure that it's called that function, which is change data, and then change data is called update with the relevant subset, and that should get you the same code to render all of that then, and do that same update. All of those updates, right, should be handled by that exact same code. So you need to make sure you do have that enter update exit in that update step, because that's going to get called over and over and over again for every single thing. Nope, those are there, you should just leave them, and is it giving you the error Yeah, I'd look at office hours because I believe if you look at the way I'll double check it, because this is, let's actually do, import, rather than running the solution, we'll run servers. Yeah, here's the exact same thing. We look at our vanilla, JavaScript console, failed to load a fave icon, but aside from that, that's the only error I'm seeing.
So I've got just makes sense. Exit remove. It works.
So I would start by debugging by looking at grabbing a fresh version and seeing whether or not it's producing that error and it's still producing that error. Then I ping Slack with how it's producing it so we can try to track down what's going on. And if it's not doing it the default one, then you can try to start adding the code back in to figure out where that might be, that error might be coming from. Yeah. No, you shouldn't have to. So, if there's an error being thrown, you might be updating something that is relying on in a way that it's not expecting. But if that's not happening, there is a potential that it's a browser update issue or it's something like this. And like if it's happening in the vanilla version that we put out, send us the details and we'll help you try to figure out what's going on there. Okay. Yep.
Because that specific part is.
You shouldn't have to.
I want to say that just wants to like so whenever you have this
So the previous version of the assignment had two separate functions.
you want it to like update.
This version of the assignment,
You want it to like actually
we look at what's going on in later.
Okay.
What's going on in the code that we gave you.
Why do we need to change this?
Is a handler
The next thing
that
sorry.
is going to check whether or not
So we know I've got the padding thing that explains.
random is checked and updated accordingly. So what you do is rather than, so basically the function that you need to make sure is linked to either
My question is-
both your data set update here and your random subset update. Both of these should on click or on change call the exact same function, which is update data. No, call update data. Update data will call random
So basically,
if this element is
right. So if I do this
Right. So the change data function. Yes. So when basically the change of the checkbox and the dropdown should both call change data. And provided they both call change data, everything should work. Because this change data function will check whether or not that checkbox is checked or not. And if so, it will grab a subset of the data and it will call the update function on just a subset of the data. And if it's not, it'll call an update function on all of the data.
So document get out of my
Uh-huh. So
Get out by.
for jobs.
Yeah, document. And then do the query.
Yep.
Yeah, so it's like
All the rest.
So I'll give you an array of what.
So in order to get it set, you have to call get and set. Uh-huh. Yeah, if that works, if it works, it should be fine. As long as we're not using D3 for it and using the actual dot attribute function of the, it should.
I wanted to show the original one slides, but this is like
Okay.
so helpful.
I think you should
Because
back.
on hand, one button,
You could bring the solution into some of these office hours on
select
or
this, query selector all, it gives you like this impact, gives you examples.
well, I'll take a look
It was
just
so
because
helpful.
I want to make sure that I'm giving you the correct answer.
Yeah, so it's like one of those things.
In any case, we can stop this.
Beyond mouse over.
Bye, guys.